Hi guys, so today we are going to start one of the most interesting and important topic of data structure, so that is stack. So in this particular lecture what we are going to study, we will obviously study the definition and we will take some examples, so exciting examples actually. So then we will understand applications and the operations. In the next subsequent video we will implementation, we will go for the implementation, but we are going to cover these things. Okay, so before going to start the topic, just I want to say that if you are new to this particular channel, just please subscribe this one and press the bell icon so that you can get some notification whenever I upload some videos. So let's understand what is a stack. Stack, the definition is here, it is a linear data structure. Okay, it is a linear data structure where elements are stored or which follows LIFO principle. What does that mean, LIFO? LIFO means last in, first out. So that is the principle of stack. What does that mean? That means the element which has been inserted at the last, that going to be removed first. So that's the principle. Last in, that means who has come in last, that going to be removed first or must be out first. So that's the concept of LIFO. Okay, LIFO. So let's understand an example. I have a actually tennis ball. So if you like tennis ball, then that's good. So then here is the tennis ball example. Okay, I will take this example. If you understand this example, okay, so this is also a stack, we can say. If you understand this particular tennis ball example, then we will map that one into our computer science terms, right? What are the different push, pop, and all the operations is full and all these things. So that is computer science terminology. We'll go to that, but let's understand this particular how this particular stack is behaved. So if you'll see how many balls are there, if you look into carefully, 1 2 3 3 number of balls are there. Can I put a fourth ball? Answer is no. So I will draw this similar picture here actually. Okay, I will draw the similar picture. This particular ball or this particular box have 3 number of spaces. Okay, that means it can contain maximum 3. That means size of this particular box, so this is the box. Okay, size of this particular box is 3, right? Okay, so size of this particular box is 3. So if you think about, so if I want to put a ball or a remove a ball, so where I will do that? Can you tell me? Can you think about it? Every time I need to do it here only, right? Can I push it here? Can I put this ball below to this ball? No, right? I need to put it here only, right? So that is known as insertion. If I want to put it here, so this is known as insertion. So I am just inserting one element, right? Inserting a ball. So this is known as insertion. You can say insertion. We'll map, don't worry, we'll map into stack terminology, but this is known as insertion a ball or inserting a ball. Okay, let's understand this one. If you understand this one perfectly, then we'll able to map this one into computer science terminology, that is stack terminology. Don't worry about that. So this is known as insertion. Suppose I want to remove one ball. Suppose I need a ball to play, so then what I will do, I will remove this one, right? I will remove this one. So this is known as removal of a ball. Okay, this is the second, because these are the things, this is the second. Okay, and the third thing is that, have you marked one thing, that every time if I want to insert an element or insert a ball or remove a ball, I need to do it in here only. That means at the top. I cannot remove it from the middle, right? Can I get that ball? Before getting that ball, I must remove this one, right? This top element, right? So that means everything is happening at one end. It is not happening at this end, right? Or not at the middle. Everything is happening at the, that is known as top, at the top end. If suppose 2 balls are there, then every operation has to be happen here only. This is known as top, right? Top. That means if I want to put an element, then I will put it here. If I want to remove one element, then I will remove it here. That means everything is going to happen at the top end, right? So that's the end. Okay. So think about this situation now. So suppose this particular box is full now, right? Can I put another ball? No, right? Because it is already full. So that is the concept of is full or full. Third is full. Then third you can say top. Then fourth is full. And if no balls are there, suppose I will remove all the 3 balls. Suppose I will remove all the 3 balls now. Now it is empty, right? Now it is empty. But I will ask that, okay, give me one more ball. Can I give it? No balls are there. So how can I give it, right? So that is known as empty. Okay. And if remember one thing, suppose this is full. suppose this is full, I will try to push an element, or I will try to put one more ball, then can I push it or can I put it? No, right? So that is known as overflow, right? Overflow means if it is already full and you want to push it, or you want to put another ball, then it is overflow, right? I cannot put it. So suppose if it is empty, that means no ball is there, but still I am asking, okay, give me a ball. Where I will give? It is empty, right? Suppose I will remove all the ball and it is empty. I cannot give, right? So that is known as underflow. So I hope you guys understand, right? So with respect to this box example, if you understand, just try to, if you have any doubts, just try to rewind and see and understand each and every concept. So what will happen now? Now I am going to map all these things into a stack terminology. So if a stack is there, stack is also a array, right? So if it is like box, it is a array. But remember one thing, it follows last in first out. That means the ball which has inserted in at the last, that is going to be removed the first. So that's what the principle is, and that is the very key principle. That's why it is concept of stack. Okay, so then there are concepts, so which is known as, now I am writing stack. So this was maybe some real world ball example. I will map this one. Okay, so now I will map this one. Okay, so what is the definition? Definition we understand, that linear data structure which follows LIFO principle, last in first in principle. So examples we have already just seen. This is a small example, practical example, or what is the applications, that we will go later, but this is the example. So let's understand the operations. So whatever the things we have written actually here, unknowingly these are the operations. So whenever I am telling inserting a ball, this is known as push a ball, or push an element into the stack. So if it is a stack, now I am not telling it as a, earlier I was telling it as a box, now I will just rename this one, I will tell it as a stack. That's the difference. Okay, that's the difference. I will put a mark here and I will start here maybe. Okay, so this is a stack now. Now if a stack is there, then what are the terminologies involved in the stack? There are some of the terminologies. One is the size of the stack, which is exactly same as the size of this particular box. So what is the size of this particular stack? It is an array. Stack is nothing but an array, but which follows LIFO principle. That's meaning how many elements it can contain? 3 elements, right? So that's why size of this particular stack is 3, right? So now, so this is the size of the stack. Suppose some elements are already there. Okay. Now if I will ask, what is the top of the stack? So top is the element. Top is the element. What is the top? Top is the end where every insertion or deletion will happen. So where I will insert this element? Here, right? If I will delete it, I will delete this particular element. So that's why this is the top. So top equal to, in this example, suppose this is index 0, 1, 2. So this is top equal to 1 in this particular, with respect to this example. And this is the, what is the definition? Definition of top. It is the end where each operation is going to be performed. That means push and pop or insertion and deletion needs to be performed. Okay. So these are the some terminology. Okay, terminology. But if we will come to the operations. So what are the operations basically? What are the operations are performed? I can insert an element, I can delete an element, I can check whether the stack is empty or whether the stack is full. So that's what are the operations. So earlier it was inserting a ball, but in case of stack, that insertion is known as push. Push an element. Push, you are inserting an element, suppose 30 or something. Okay, so that is known as push. So I am just writing this way. Okay, so this is nothing but the insertion. This is mapped to insertion. If you remember, this is mapped to insertion. Now how about a removal of a ball? That is in stack terminology that is known as pop. Pop. Okay, what is a pop? Push means inserting an element. If you will think about this one, what is a push? Definition: inserting an element into a stack, or inserting a ball. That's fine. But inserting an element into the stack. Okay, just insert an element. So how about pop? Delete an element from the stack. So that's what we need to do. And from where I can delete? From the top of the stack. That's very important. Okay. Then the third point is is full. Okay, is full. So before going there, okay, is full. What does this is a method or this is a mechanism. What does this returns? This will return a boolean. We will go for the implementation maybe in the next class with a detailed explanation with the algorithms. Okay, but what is the is full? We'll check. It will check whether the stack is full or not. Okay, so if it is full, then it will return. Okay, so stack is full. Okay, then fourth is empty. Okay, is empty is what? It will check whether that stack is empty or not. Okay, so that's what it is telling. So then the fifth is pick. So this will check what is the top. So if I'll ask you what is the top in this particular example, so pick will return that particular answer, that is 1 it is going to return. Okay, so this is what all about the stack. Okay, so push, these are the operations: push, pop. Push means insert an element into the stack, pop means remove one element from the stack, and is full means whether the stack is full. Okay, it will return. If stack empty means whether the stack is empty. Okay, pick means find where the top element, right? So then the question is, what are the applications of stack and how to implement all these things? I hope you guys are following. So what are the applications? So if you think about a browser example, okay, so you guys must be using, so you are pressing the back button, right? So if you have visited 10 pages, in one pages you have did the 100 number of searches and you are pressing back button, it will go to which one? The recent one which has been you have visited, right? So that's what it will do, because that uses the concept of stack. There are a lot of other examples like recursion. If you think about, recursion uses stack. If you are writing a recursion program in C, C++, Java or any language, that's fine, that's I am not concerned. But if you are using recursion, that is being maintained as a stack. If you have studied some recursion, that's okay, we will, otherwise we will discuss also, not to worry, but that's fine. But it internally maintains the stack. Okay, and that is the responsibility of the compiler or the operating system. That's we are not taking care. If you are writing a recursive algorithm, just write a recursive factorial of n, then n into factorial of n minus 1. So that's what we are writing, but internally it is maintaining all the stack. What do you mean by stack? That means it is maintaining all these things. Okay, so let's wind up this one here, and we'll in the next class we'll take a simple example and we'll understand how this particular stack will behave. Okay, so thank you, and if you have not subscribed or you want to check out our website, so just check out. We have a lot of different we provide different coaching, like preparing for the UGC net, GATE and all these things, and also preparing for your interviews. So if you are interested, just check out, and please don't forget to subscribe this channel and press the bell icon. Thank you. We'll see you in the